This is a video from section 4.8 in linear algebra. The directions say to express the product AX as a linear combination of the column vectors of A. Let's take a look at 1A. Suppose we're given the matrix 2, 3, negative 1, 4 times the column vector 1, 2. So this can be written as 1 times the column vector 2, negative 1 plus 2 times the column vector 3, 4. And so notice how the column vector 2, negative 1 corresponds to the first column of matrix A, and the column vector 3, 4 corresponds to the second column of matrix A. In 1B, suppose I'm given the matrix 4, 0, negative 1, 3, 6, 2, 0, negative 1, 4 times the column vector negative 2, 3, 5. So this is negative 2 times the column vector 4, 3, 0 plus 3 times the column vector 0, 6, negative 1 plus 5 times the column vector negative 1, 2, 4. And notice, again, the column vector 4, 3, 0 corresponds to the first column of matrix A. The column vector 0, 6, negative 1 corresponds to the second column of matrix A. And the column vector negative 1, 2, 4 corresponds to the third column of matrix A. 5. Suppose x1 equals 3, x2 equals 0, x3 equals negative 1, x4 equals 5 is a solution of a non-homogeneous system AX equal B. The solution set of the homogeneous system AX equals 0 is given by x1 equals 5r minus 2s, x2 equals s, x3 equals s plus t, and x4 equals t. Find a vector form of the general solution to ax equals 0. Okay, that's part A. Part B, find a vector form of the general solution to ax equal b. So let's take a look at A first. So I restate the question and say find a vector form of the general solution to ax equals 0. So I'm looking at the column vector x1, x2, x3, x4. This is equal to the column vector 5r minus 2s, s, s plus t, and t. Now, notice, we can write this as the column vector 5r, 0, 0, 0. So notice I see 3 parameters. So if I see 3 parameters, I should have the sum of 3 vectors. And I'm going to go plus, and then I'm going to go negative 2s, s, right? S, 0. Plus. Then I'm going to go 0 for the first entry, 0, t, t. And so that's basically what I did over here. So I have the column vector x1, x2, x3, x4. This is the column vector 5r, 0, 0, 0, plus the column vector negative 2s, s, s, 0, plus the column vector 0, 0, tt. And so this is r times the column vector 5, 0, 0, 0, plus s times the column vector negative 2, 1, 1, 0, plus t times the column vector 0, 0, 1, 1. Now, in part B, it says find a vector form of the general solution of ax equal b. So now we have a specific solution to ax equal b. We have a solution to ax equals 0. If we add them up, we get a solution to the non-homogeneous system ax equal b. And so here, I'll write it this way. So the general solution will look like the following. Now, I'm going to take the specific solution to ax equal b, or the particular solution for you differential equations people. So I get 3, 0, negative 1, 5, right? That's the specific solution. And then what I'm going to do is I'm going to add the general solution to ax equals 0. So I'm going to take r times, if we go back, 5, 0, 0, 0. Oh, let's go back here. 5, 0, 0, 0. Plus s times, and then it's going to be negative 2, 1, 1, 0. Plus t times, and then we get 0, 0, 1, 1. So notice how we have a specific solution to ax equal b. We have a general solution to ax equals 0. And if we add them up, we get a general solution to ax equal, or a solution to ax equal b. It's a general solution because r, s, and t are free variables. So, okay. That'll do it for this video. This is section 4.8, and we looked at problems 1 and 5. Thank you.